Okay, welcome to this video on the slope, distance, and midpoint formulas. Personally, I try not to rely on formulas too much because it's easy to use a formula if you don't understand the underlying concept behind it. So I try to, and make a mistake when you use a formula like that. So I try to avoid using them unless I really understand the concepts. But they do have their time and place, and so it's important that you know how to use these formulas correctly. These are all taught together because they all use the same kind of values in the same way. Alright, let's take a look at the slope formula. The slope formula, basically the concept behind slope is that the slope is a measure of the slant of the line, right? It's the distance we go up or down divided by the distance to the right. So when we were doing slope before, we were saying things like find 2 points and look at how far up or down, in this case 3 down, and then 2 to the right, and then know that the slope is therefore the distance that we go up or down, which is -3 in this case because it's down 3 and then 2 to the right. So the slope of this line is -3/2. And I like that way of finding slope because it's conceptual and it ties to our idea of that. But there is a formula called the slope formula, and it's this right here. Slope is y2 minus y1 divided by x2 minus x1. So we should see where that comes from. Well, here were the 2 points marked that I used when I found the slope the other way, right? I looked at the distance that we went down, and I divided it by the distance that we went to the right, okay? Well, the other way to do this is to take the 2 points, and you can call one of them point 1 and one of them point 2, and each point has an x and a y. So if we use this point 4 comma 2 as point 1, then it has an x and a y, and so we mark that as x for point 1 and y for point 1, or just x1, y1. So the x1 value is 4 because it's the x coordinate of point 1, and y1 is 2. It's the y coordinate of point 1. Okay, then the other point, which we called 2 comma 5, we called that point 2. It has an x and a y coordinate, and so that's labeled x2 and y2. So it's important to know that these symbols here, x1 or x2, doesn't mean x times 2 or x squared or anything like that. It's just the x coordinate for 2. So whenever I see, for example, an x2, I'm going to substitute the whole value of 2 in for that. It replaces it. Wherever I see a y2, I'm going to substitute a 5, and so on. Okay? So using these formulas, right, the slope formula says, if I just plug it in, right, to use it, then I just substitute the 4 numbers from the points, right? You just pick a point to call 1, make x1, y1. Pick a point to call 2, make x2, y2. In this case, the y2 value is a 5. Then you subtract, the formula has a subtract, minus the y1 value, which is a 2, right? And then you take the x2 value, right, which is a 2, and then you subtract the x1 value, which is a 4. So I'm just substituting those things in there. And so we would have 5 minus 2 is 3, and 2 minus 4 is -2. And so that's the same as -3/2, the same thing we found before. Now the reason that that works that way is, if you go back to the picture, right, let me erase some of this because it's getting kind of cluttered, right? Why is this distance right here, why is this distance x minus 2? Well, if you look at this distance right here, okay, that's going to be y2 minus y1 because y2, right, y2 is how far up point 2 is, and y1 is how far up point 1 is. And so the difference between those two is just that amount up or down. And that's why the top of this formula here, the top of this formula says y2 minus y1. It's just that distance. It's the difference in the y coordinates, right? And the same thing is true in the x direction, right? If we have we wanted to know this distance, well, that distance is going to be, you know, the distance to the difference between the distance in the x direction for 1 and 2. Okay, so that's why the formula is in this form. It's a difference in the y's, which is the amount up or down, divided by a distance to the right, which is the difference in the x's. Okay, but using the formula itself is pretty straightforward. So let's just do it one more time. Another example, same idea. I got 2 points marked here. I chose to make the left point -3 comma -3 the point 1, so that means x1 is -3 and y1 is -3, and I chose to make the second point on the right the point 2, so 4 is going to be x2 and 1 is going to be y2. So see if you can plug the numbers in appropriately for these values, okay? And I'll erase that again so you can see that better. Pause the video, come up with the slope. Okay, so if you did this correctly, For y2, you use the number 1, and for y1, you use the number -3, and then for x2, you use the number 4, and then for x1, you use the number -3. So that means the slope, well, let's see, if I have a negative, that makes this a positive, right? These cancel to a positive, so it's 1 plus 3 on the top, and it's 4 plus 7 on the or 4 plus 3 on the bottom. So the correct slope should be 4/7, okay? And the point I'm illustrating here is that it doesn't matter whether some of these x and y values are negative, right? As long as you're careful with your subtracting a negative and making that a positive, and remembering that there is a negative in the formula, so there might be a negative of a negative, then you'll get the correct distance even if the x's and y's are negative. Okay, so just be really careful with your negative signs. Okay, so that's the slope formula, and it is a quick way to find the slope. Let's do another one. Let's see. I don't even need a graph here necessarily. I could just say if I've got these 2 points, I can just pick one of them to call point 1, and one of them will be point 2, and that makes this the x and the y for point 1, and the x and the y for point 2. I would recommend at first that you label it just like that, so that you can have numbers to plug in. So for y2, we'd be plugging in a 3, right? y2 is 3. And then minus y1 is -1, x2 is 5, and then minus 3 for x1. So I would have, let's see, 3 plus 1, which is 4, over 5 minus 3 is 2, and that simplifies to 2. So it looks like the slope here is +2. Okay, slope is +2. And I don't even need to graph that to find that if I'm just using the formula. All right, so that's the slope formula. Now, we're going to talk about distance formula and midpoint formula because they use the same meaning for x1, y1, x2, y2, okay? But they're doing different things, right? Slope formula is finding the slope of a line, so it's a number representing the slantiness of the line. Okay, the second formula we're going to talk about is called the distance formula. And for this one, it's really, the distance formula is just a pre-solved version of the Pythagorean theorem. So if you remember from geometry, you have the Pythagorean theorem says if you have a right triangle, and you know 2 of the sides, you can find the third side because the long side squared is always equal to one of the short sides squared plus the other short side squared. So in this case, d squared equals a squared plus b squared. I know a lot of times we use letters c squared equals a squared plus b squared, or maybe we wrote it as a squared plus b squared equals c squared, but the order doesn't matter as long as the long side is the one that's by itself, right? And then I'm going to call it d because that's what we're going to call it when we do the distance formula. Okay, so in this case, right, I would have an unknown length d squared, and let's say that a and b were 7 and 4. So this would be 7 squared plus 4 squared. So d squared is 49 plus 16, and that's going to be, what is that? 65, right? 65. And so to get d by itself, I have to undo squaring, so I would take the square root of both sides, right? And that means d would be the square root of 65, which I can't simplify. Now, you might be thinking I should put a plus or minus there, and you'd be right, except that since I'm talking about a distance can't really be negative. So we would say it's the square root of 65. So we do have a conceptual way to do this with the Pythagorean theorem. Okay, distance formula is just another way to do that. I've got the same triangle here, a distance of 7, a distance of 4, but let me put it on a grid. What if I had points here, where this point was 4, 1, and this point was at -3, -3, and I wanted to find the distance between those 2 points, the distance d. Well, that a is just x2 minus x1, the same way as it was for slope, and the b is just the difference in the y's, y2 minus y1. So really, this distance squared is a squared plus b squared is really just distance squared is the difference in the x's squared, that's the a squared, plus the difference in the y squared, right? And then you just take the square root of both sides, you get what's called the distance formula. So that's the distance formula. It's just a pre-solved out version of the Pythagorean theorem. To use it, you just have to plug in the values carefully from the points, right? So in this case, x2 would be a 4, right? Minus x1 is a -3, and then that whole thing is squared, plus y2, which is 1, minus y3, which is a -3, and that whole thing is squared. And all that's under a square root. Then you have to carefully simplify. So you've got square root. This is 4 plus 3, so that's going to be 7 squared. And that's going to be 1 plus 3 is 4 squared. See, same 7 and 4 as we got when we did this as a triangle. And then d is the square root of 49 plus 16, which is the square root of 65. The same thing we got with the other example. All right. So if you feel like you have this idea, try this one. Same idea. Okay, well, let's see. Let's call this point 1, so it has an xy. Let's call this point 2, it has an xy. I can just use the formula then without graphing. x2 would be 3 minus x1 is 6 squared plus y2 is 5 minus x2 is negative 2 squared. All right, so I've got distance is square root of negative 3 squared plus 7 squared. So that's going to be 9 plus 49, right? And that's going to be 9 and 9 are 18, so square root of 58. And I don't think that simplifies any, so we would just leave it like that, square root of 58. All right, one last formula to talk about along the lines, the midpoint formula. It almost is the same thing. The midpoint formula, though, instead of finding a distance, says you already have a line segment that's connected by 2 points, and we have the coordinates of the endpoints, and we want to know the coordinates of the middle point. So if you think about it, really, the x in the middle here, this has got some x value and a y value. Well, this x is halfway between these two x's, right? This x is halfway between these two x's. So it's really the average of the two endpoint x's, and the y's are the y in the for the midpoint is the average of the two y's. And so I think of the midpoint as the average x and the average y. And so it's the same thing, x1 plus x2. A lot of times these are reversed. We'll have x1, x doesn't matter, right? We're just going to add the two x values up and divide by 2 to find the average for both the x and the y. But again, you don't need to have the whole picture in order to use the formula. If I made 2, 1, 0.1 and 6, 7.2, I would just take the two x values. Let's see, x2 plus 6 divided by 2 to take the average, and then I would take the average of the y values. So I'm plugging in for x and x1, y1, x2, y2. So 8 divided by 2 is 4, and 8 divided by 2 is 4 also. So it looks like the midpoint here is the point 4, 4. Okay, so this is different, right? The midpoint formula doesn't just give a number, it gives a point that has an x and a y coordinate. All right, same idea though. x1, y1, x2, y2 are used the same way. Okay, let's do one more without the picture, so I'm not going to use the picture. I'm just going to label this as point 1, has an x and a y, and this is point 2, has an x and a y. All right, let's just plug numbers in here. Let's see, we've got x2 is 3 plus x1 is negative 4. It is important to note that in this formula we have pluses, whereas the other two formulas had minuses there. All right, and then what do we have here? We have y2 is 8 plus y1 is negative 2 over 2. Okay, so what have we got? I've got negative 1 over 2, and 8 minus 2 is 6 over 2, but 6 over 2 is 3. Okay, so that would be the midpoint. Negative 1/2, 3. All right, summary. The slope, distance, and midpoint formulas, they all use xy coordinate values for 2 points. And they use them in the same way. It doesn't matter which point you label point 1, just be consistent, be careful with negatives, but you should realize that the three formulas are doing very different things. The slope formula is finding the slant of the slope of the line, right? A distance formula is finding a distance between 2 points, and a midpoint is finding the coordinates, the xy coordinates of the midpoint of a line segment given the end point coordinates.